There are various levels of inspection, because for every dam one cannot have the highest level of expertise made available every time. It's a humanly impossible kind of task. So we have to devise the levels of inspection. Various levels of inspections are associated with various frequencies. The lowest level inspection will have the highest level of frequency, and with that the issues get generated, and then those issues are the ones which will get addressed through the dam safety assurance programs. So the CWC guidelines develops a various category of inspections, like the comprehensive evaluation inspections, the scheduled inspections. Scheduled inspections are most frequent, where every monsoon, every pre and post monsoon period, you have to inspect the dam by a generally competent engineer who has some familiarity with the dam and provide indicators about the performance of the dam. With that, there may be need for escalation, or if there are no need for escalation, then every longer period of interval, say for example about 10 years interval, the entire safety environment of the dam has to be re-evaluated, because the natural phenomenon data becomes available, more data becomes available. Suppose we have constructed the dam with the observation data which was restricted to about say 35 or 40 years, then after 10 years that same data length will become 50 years. Some other extreme events may have occurred during the period. Similarly, the material would have undergone some significant transformation during those 10 years because of various reasons, and comprehensive evaluation becomes necessary. At times, if some very worrying features are noticed even during scheduled inspections, we may have to have unscheduled special inspections, where we carry out these inspections in order to see that the inspection that the phenomena that is developing, how to tackle them. There are other informal inspections that may also happen as well. Earlier guidelines of CWC used to provide as a phase 1 inspection and phase 2 inspection, which primarily looked at the scheduled inspections and comprehensive evaluation inspections in a general manner. USBR defines it again in a similar manner, but then one can see that the levels as adopted have to provide for these three parts. That is, one is the pre and post monsoon inspections for continued surveillance and early warning, comprehensive dam safety review exercises on a regular basis of say 10 years or so, and special inspections for identified problems and remediation exercises. In fact, the dam safety legislation, as and when it will get approved by the Parliament, has a lot of attention to the first two levels of inspection, how they should be carried out, who is responsible for that inspection, what are the actions that are required to be taken. So these inspections will then start getting the legal strength once this Dam Safety Act comes into operation. In many of the advanced countries like USA or Canada or various other countries, these kind of legislations have already been adopted, and the agencies who are owning the dams are required by law to carry out these inspections in a systematic manner and report it to the government and to the controlling authorities. So levels of inspections are something which have to be defined by the dam owner, and they have to be in line with the possible practices and legislation, so that these inspections are able to generate the outputs which can lead to a safety assured dam. Observation program in informed decision making. Now this is an ingredient which is largely associated with the dam operators. There are multiple types of observation programs. One of the main program for the hydrological monitoring, where the inflow floods are related, where the establishment of a system of hydrometeorological stations for inflow forecasting becomes a must, especially for the large dams and those dams which are also located in a cascade, with large catchments behind them. So we should know what is the kind of phenomena that is developing in the catchment area, and what are the potential floods that this area under this influence of these phenomena will be able to develop. Then the collection and processing of this real-time data during the periods of floods is very important, because that will provide you with the quantitative warnings. Then the establishment of a real-time flood forecasting model for estimating the potential inflow floods, so that you have a quantitative idea about the volume of water that is likely to come in the reservoir, where it will lead to the reservoir levels, what kind of outflow process strategies that will have to be adopted so that the dam remains safe, and you are also in a position to provide forewarning to the downstream areas for their emergency action planning, that this level of outflows are expected at these points of time. So disaster management agencies can start their preparations well in advance. Setting up of the standard operating procedures, again based on the observation program, so that the adequate warnings are generated and everybody is safety assured. Reliable real-time communication lines, we just discussed a little earlier. Especially this is very critical for the dams in cascade. If there are multiple dams on the same river or in the same basin, then one of the operation of the dam may influence the other dam which may be downstream, and this combined can create a catastrophe which may have a domino effect and which may multiply if it is not handled properly. In Himalayan glaciated regions, the observation program, especially for the glacial lake outburst flood, is very important, because this flood is a very flash flood that gets generated, and that is very hazardous for the safety of the dam. Structural behavior of the dam is another place where the observation program has to be there for all dams. The provision of embedded instrumentation at the time of construction for large dams is a requirement. However, in our country, we have a difficulty in maintaining a very safe and sound instrumentation system in many of our major dams. The instrumentation systems go out of order very quickly, or they are not implemented properly, and the structural behavior as reflected by them is not available for the safety evaluation. But still, there are minimum requirements that are based on the dam type, and the minimum requirements are that in case of the concrete or masonry dams, the deformation or the deflection of the dam and the uplift in the dam, as well as the pore pressures in the dam and the quantum of seepage through the dam, are the absolute minimum requirements which have to be implemented, so that we have at least some idea about the status of the dam. Likewise, the pore pressures in an earth and rockfill dam, the seepage discharges at the downstream toe and through the relief wells, and various other conditions of slushy ground, etc. on the downstream, the profile of the slope, the settlement of the surface of the earth dams or rockfill dams. These are the minimum requirements which have to be ensured every time we operate a dam. Regular structural behavior reports have to be prepared, and they have to be reviewed regularly at the expertise level, where the phenomena, if any, is developing, then that has to be arrested, or that has to be analyzed and then provided the remedial measures for. Any unusual behavior should be investigated using the numerical and physical investigations and modeling. So observation program becomes an input to such exercises of modeling, which can then work out the impacts of very complex phenomena, and then also lead to development of the remedial measures. Deficiency investigations for the dam is a very critical area. What is lacking? The dam will only exhibit a symptom. Dam will indicate that there are cracks here, that there are some deformation here, but then these are the signs, these are the symptoms. what has caused those symptoms is equally important. If those causative factors are not understood, then we may take some measures which may give us a temporary relief, but then again this phenomena may again come back in a virulent form. It is something similar to taking a paracetamol for a fever, which may be originating in some very serious phenomena in the body, and temporarily the fever may go away, but the causative reason will not go away, and it may cause the fever again, and at that time some extra disease manifestation may also come up, and we may have to attend the whole situation in an emergency. So this is the role of deficiency investigations for the dam. The types of deficiencies are that the deficiencies may arise out of the insufficient capacities. Sometimes the operations are done in an inconsistent manner, and because of that a deficiency gets arisen, which leads to erosions, which leads to various other cracking or some other phenomena, and then they have to be treated. Development of deteriorative phenomena, which we discussed earlier as a part of the material's aging, where the deterioration occurs in the dam material, and that deterioration has to be arrested, and for that what is causing the deterioration has to be analyzed. That's a very long exercise, and that is the part of the deficiency investigations. Unforeseen phenomena that occur under maybe some extreme circumstances like very heavy rainfalls or various other areas, then landslides, slips, or some other such things that may occur. And for that, what caused the deficiency and what are the underlying roots which have led to that kind of a mishap have to be investigated, and then based on that the remedial measures will have to be provided. Deficiency investigations always involve sampling of the dam materials, drilling, trial pits, and various other surveying and geophysical techniques. Structural part, where we may have to carry out geotechnical mapping of the joint patterns of the openings, surveying above or underwater to inspect the various parts of the dam and note down their conditions. Instrumentation records, from which also we may know some unusual phenomena taking place. Historical records of occurrence of storms or glacial lake outbursts or seismic events. These are the deficiencies, these are the issues through which we may be able to generate the causative factors for the deficiencies noticed, so that we can provide the remedial measures. We may also have to employ the geophysical investigation techniques, which are like seismic or other tomography, ground penetrating radar, streaming potential, and many others. In fact, there is a whole section of this particular course which will be devoted to the use of these techniques and how the techniques are capable of providing you the insight into the deficiencies that are noticed for the dam. And this is a very important aspect for the dam safety management part. Underwater inspection again requires a very specialized man, specialized equipments and materials for repairs. Outcomes of investigations for the deficiencies have to be generated in a consumable fashion for formation of remedial measures. The deficiency is not merely a deficiency. We have to find a solution to it. So the investigations have to ultimately lead to an insight which is capable of providing us with a solution in any manner. We may even choose to live with the deficiency after investigating the deficiency, but it should provide an insight to us. So we will have a lot of focus in the course for this area of how to investigate the deficiencies and then how to provide for their consistent repairs. Analytical studies are a very important part of dam safety management these days. Once a deficiency is noticed, many times this deficiency has arisen because the dam performed outside their design plans, outside the design idealization. When you have a particular design, you idealize the structure, the behavior of the structure in a particular manner, and then you design the dam. But then this deficiency has occurred because this idealization did not remain valid during the occurrence of a particular phenomena. So design procedures may not be able to provide insight into the distress phenomena straight away. There may be some additional insights will be necessary. The designs have been generally developed on the basis of certain very simplifying assumptions. For example, the assumption that the dam is a rigid structure, the foundation is also rigid, and that way a concrete dam will behave like a one rigid block sitting on the other rigid block, or an earth dam in which the slips are occurred or slips are supposed to occur in a particular manner under a slip circle kind of analysis. So these idealizations may not remain valid when there are variations in the densities of the dam within the body, or when there are certain other phenomena. Another major aspect of departure is in the seismic part of the behavior of the dam. Because dam is an elastic medium which is sitting on another elastic medium, that is the foundation, and these medium are not indefinitely elastic, they are basically what we can call elasto-viscoplastic. And there are also discrete behavior of these individual elements because of the discontinuities that may exist. So all these kind of aspects have to be understood using the new numerical modeling techniques, which is an essential tool for simulating the behavior of the dam. Multiple methods are available, which we have discussed in your lecture notes. You will be able to see it over there. And the understanding has to be developed that which is the type of simulation which is more relevant for the given phenomena, and then how to carry out that simulation. This is again a matter of a lot of expertise, a lot of experience, and very experienced persons have to be involved in that. Otherwise, there are also chances that we may do a lot of sophisticated analysis, but then we may not come out with any insights. So the selection of the method, selection of the material properties, setting up of the analytical program needs a lot of care and many repeated trials. And always the tendency has to be to go from a simpler analysis to a complex analysis. A simpler analysis is very easy to visualize. The visualization through the simplified analysis provide you with the hints that when you want to make it more complex, is that more complex analysis is providing you with greater insight, or it creates more confusion by raising more questions. So the studies have to be planned with a great strategy and with good amount of experience. Physical modeling studies are also necessary, especially for the hydraulic problems like the erosion. We have a very severe problem of uncontrolled erosion downstream of the energy dissipation arrangements, especially in the ski jump buckets and in the roller buckets, where the mathematical formulations are not adequate. There are various site conditions which cannot be replicated exactly in a mathematical model, but then physical model may also be necessary to see that if we make some changes, how they are likely to perform, or the existing changes that have occurred, how they are actually behaving under extreme floods. So physical modeling as well as analytical modeling are important exercises where some serious deficiencies are noticed, and where the dam has got sufficient amount of importance and resources and hazard potential to undergo these exercises. Let us now examine the rehabilitation requirements. Having gone through the entire exercise of ensuring dam safety, there are likelihoods that every frequent interval, like say 10 years or so, we may land up with some rehabilitation requirements. So there are different types of rehabilitation requirements for different types of dams. Generally, we can put concrete and masonry dams in one category and earth and rockfill dams in another category. Since we do not have many arch dams, we are not concentrating on arch dams in this particular part of the presentation. So what are the rehabilitation requirements for concrete masonry dams? First and foremost is the structural integrity. As we have discussed earlier, cracking occurs due to thermal stresses, alkali-silica reaction, foundation settlement, chemical attacks, overloading, and some other aspects as well. This cracking has to be repaired, and for that specialized materials and techniques have to be used. Very large cracks, which are structural cracks and endangering the overturning stability of the dam, may have to be stitched with the help of pre-stressing mechanisms and then grouted. Some of the other cracks, like those generating out of thermal stresses or alkali silica reaction, etc., we may have to grout them with specialized materials. And for chemical attacks, we may have to remove the spalled concrete, the deteriorated concrete, and then provide new concrete with polymer additives or with the additives which are capable of resisting the corrosion and attacks. There can be high performance concrete requirements in case of erosions. Another major issue of rehabilitation that comes is the seepage through dam body. Primarily, any gravity dam sits on and remains stable by way of its weight. The strength part of the concrete is not brought into play very greatly, but the weight is very important. And when seepage occurs through the dam body, it creates leaching, and this leaching and this cracking coupled will create a unsound dam, and for that the seepage has to be arrested. And for arresting the seepage, there are various other aspects like providing a membrane, carrying out grouting, carrying out the surface sealing of the cracks, and so on. There are a lot of technologies which of course you will be covering during the part of this course, where the specialized manufacturers will also expose you to the techniques that they have available and how they have used and how they have been successful in use in various conditions. Structural modifications, where we may need to provide additional spillway capacity. Now this becomes a very major construction exercise as well at times. Defensive measures for floods, like providing the telemetry in the catchment area, getting the better hydrological data and getting the better warning times. Similarly, better seismic resistance by adding crucial additions to the body of the dam and creating a body which is more amenable to the resistance to the seismic forces of a higher magnitude than it was designed for. Hydraulic issues like erosion repairs for energy dissipation or downstream channel, and also sealing, they will also require some good amount of underwater works as well. There may be possibilities of dewatering some parts of the downstream channel, but many times the defects are so large and dewatering becomes very difficult and a very time consuming exercise. So underwater works are also important, and fair amount of underwater works may get involved in such erosion repairs, or using special techniques like using a pneumatic caisson as is being done in case of Bakra project or many other places, and then carrying out the repairs with special concrete. Geotechnical part, where we need to look at the abutments. There may be some slope instability in the abutments because of the erosions or because of various other disturbances like excavation of roads or some other deterioration because of the wave action in the downstream channel or in the reservoir. And the slope stability have to be improved. Maybe depending upon the type of slope, we may have to provide with different measures. Like in case of the soil slopes, there can be soil nailing and such measures, whereas in case of the rock slopes, we may have to do stitching with the help of rock bolts and shotcreting, drainages, etc. Foundation improvement, where we find that the foundation has got excessive seepages or foundation requires certain strengthening, then grouting and various other providing keys in the foundation, etc. also may be required. Hydromechanical is a special part of the rehabilitation requirements, and it's a very more frequent requirement. Maintaining the gates by ensuring that the sections of their members are intact, also by looking at the paints, looking at the various bearings and various mechanisms, hoists, etc., capacity of the hoists, and any other issues that get noticed out of the regular operations. We will be dealing with this separately again with a set of specialized lectures. Restoring observation program is also equally important, and this should become a part of the rehabilitation requirements, wherein at least for the concrete and masonry dams, even if we may not be able to provide or replace the embedded instrumentation, the uplift, seepage and deformations, these three are key observation requirements which have to be set up, and for which there are mechanical and topographical survey specialized equipments means are available. Seepage measurements are relatively simple and can be implemented quite quickly, but these observation programs will also need rehabilitation.